When people talk about the limits of science, they often mean practical limits. We don't yet have powerful enough instruments. We can't build detectors large enough. We can't observe long enough or precisely enough. These are technological limits, and history shows that many of them eventually fall. But physics also contains limits of a very different kind. Some things can never be observed directly, not because of engineering challenges, but because the universe itself does not allow access to them. These are epistemic limits, not technological ones. To understand this, it's important to remember what observation means in physics. Observing something requires interaction. A signal must travel from the system being observed to the observer. That signal must arrive within a causal structure that allows it to influence a measurement. If no such interaction is possible, then no observation can occur, even in principle. This immediately rules out certain kinds of knowledge. Events beyond a cosmic horizon cannot be observed directly, because no signal from them can ever reach us. Matter beyond a black hole's event horizon cannot be observed directly, because it can no longer interact with the outside universe. These are not gaps waiting to be filled. They are boundaries enforced by space-time itself. The same is true for the exact microstates of high-entropy systems. Once information has been scrambled beyond recovery, no measurement can reconstruct it. The detailed past configuration is not hidden behind a veil waiting to be lifted. It no longer exists in an accessible form. This means physics cannot directly observe the complete past of any system. It can only infer aspects of the past from surviving records. What has been thermally erased or causally disconnected is not just unknown, it is unobservable. There is also no way to observe the universe from the outside. Any observation must occur from within the universe, using processes governed by the same laws being studied. There is no external reference frame, no global clock, and no privileged vantage point. Every observer is embedded, local, and constrained. This matters because it prevents certain questions from being physically meaningful. Physics cannot directly observe the absolute beginning of the universe, if such a thing exists. It cannot observe regions forever beyond our horizons. It cannot observe counterfactual histories that did not occur. It cannot observe the complete microstate of reality at a single moment. These are not failures of curiosity, they are reflections of how causality works. This does not mean physics is incomplete or broken, it means physics is scoped. Physics concerns itself with relationships that can be tested, correlated, and constrained by observation. When something cannot, even in principle, influence any measurement, physics does not assign it explanatory power. This is why modern physics is careful about what it claims. It does not assert knowledge of what lies beyond horizons. It does not require access to erased information. It does not assume that everything real must be observable. Instead, it builds consistent descriptions of what can be connected. This distinction is often misunderstood. People sometimes treat epistemic limits as philosophical weakness or pessimism. In reality, they are what make physics reliable. By refusing to speculate beyond causal access, physics avoids inventing explanations that cannot be tested. Knowing what cannot be observed is part of knowing what counts as evidence. These limits also explain why some questions persist without answers. Asking what happened before the universe entered an observable, persistent phase may not have a physical answer. Asking for a complete reconstruction of the past may not be meaningful. Asking for total transparency may be incompatible with entropy and horizons. None of this diminishes the power of science. Physics has shown extraordinary reach within its domain. It can reconstruct early cosmic conditions, infer unseen particles, predict behaviors far beyond everyday intuition, and test ideas across unimaginable scales. but it does so by respecting the boundaries imposed by reality itself. The universe does not promise full disclosure. It promises consistency where interaction is possible. Understanding this helps us avoid false expectations. The idea that science should eventually explain everything everywhere. That expectation misunderstands what science is for. Science is not a quest for omniscience. It is a method for building reliable knowledge under constraint. The limits we encounter are not obstacles to be overcome. They are features of the system we inhabit. And recognizing them does not shrink our understanding. It sharpens it. Physics does not tell us everything that exists. It tells us what can be known and why. My name is Charles Carroll. Thanks for taking the time to listen.